Welcome students to this lecture of refrigeration and air conditioning. In the last class we have discussed about the vapor is wet at the end of the compression. So let's proceed further to our case number 3, that is when the vapor is superheated at the end of compression. Okay. So our case is when vapor is superheated at the end of compression. So now see the corresponding TS, temperature entropy diagram, and pressure enthalpy diagram. In your PS, suppose in your TS curve, that is temperature entropy curve, let this is your saturation curve. Okay, and in your pH, this is your saturation curve. Okay, fine. So let this is the upper pressure, that is your condenser pressure, and this pressure line is your evaporator pressure. Similarly here this is your condenser pressure and this is your evaporator pressure. Clear? The case says that it is the superheated vapor at the end of compression, means if the vapor is superheated at the end of compression, means the point 2 will lie outside the dome. Okay, suppose our starting point at the entry of the compressor is dry and saturated. So students, our point number 1 will be will touch the saturation vapor curve, and as the process 1 to 2 is a isentropic compression process, so entropy at point number 1 will be same as point number 2. So here S1 will be equal to S2. So 1 to 2 is your isentropic compression process. Now 2 is superheated state. Here the corresponding temperature is your T superheated temperature. Now the there is a from 2 to 2 dash there is a temperature decrease, and it will be come back to the saturation temperature 2 dash, and from 2 dash to 3 there is a constant pressure heat rejection in the condenser, and it will be follow to the point number 3, and then 3 to 4 is your isenthalpic process. Okay, where where the enthalpy remains constant. So now look here in the corresponding PS chart, PS curve, your pressure and enthalpy curve, point number 1, point number 2, point number 3, and point number 4. H3 will be equal to H4 in process 3 and 4. And now first you will find what is the refrigeration effect. So refrigeration effect will be produced in the evaporator. So in the evaporator, what is the refrigeration effect? It is the difference of enthalpy between point number 1 and point number 4. So refrigeration effect will be H1 minus H4. And similarly, what is the work done by the compressor? That is WC will be H2 minus H1. So the process 3 to 4 is your isenthalpic process, means H3 is equal to H4. Fine. So what is the COP? COP is equal to net refrigerant effect per work done by the compressor. So COP will be refrigeration effect by compressor work. Just put all the enthalpies in terms of just put all the values of refrigeration effect in terms of enthalpies. So COP will be H1 minus H4 divided by H2 minus H1. But H4 and H3 have the same values. So replace H4 in terms of H3. So H1 minus H3 divided by H2 minus H1. Now you can find the value of enthalpy at point 1, and you can also find the value of enthalpy at point 3 very easily from the table given of the question. But you have to find the superheated enthalpy at point 2. How? So as the point 2 is in superheated state, so just apply the relationship from the properties of pure substance, that is H2 will be H2 dash plus specific heat of vapor whole into T superheated minus T saturated. Okay, and HT superheated means temperature at point 2, and T saturated means temperature at point 2 dash. Okay, and similarly you can find the entropy also. S2 will be S2 dash plus CP S ln T2 by T2 dash. Clear, students? So let's solve one numerical. So look here the question. Okay, fine. Okay, the question says a F12 vapor compression refrigeration system has a condenser temperature of 50 degrees centigrade. Means it has the upper limit temperature is 50 degrees centigrade and evaporator temperature of 0 degree centigrade. Okay, means this is the lower temperature limit. The refrigeration capacity means RC is given 7 ton. Okay, you know 1 TR 1 ton of refrigeration is equal to 3.5 kilowatt, or in terms of kilojoule per hour, you know 1 TR is equal to 14,000 kilojoule per hour. So you can convert in any unit, no problem. The liquid leaving the condenser is saturated liquid and the compression is isentropic. Okay, fine. Find the COP, heat rejected in the plant, heat extracted, and power required, mass flow rate, and degree of superheat. You have to find all the given in the question. Okay, and a table is given in the question. Here look the table very carefully. There are different columns: temperature column, pressure column, enthalpies of HF, HG, entropies of SF and SG, and the corresponding values of temperature 50 degrees centigrade is given. Similarly, the corresponding values of temperature 0 degree centigrade is also given. And one more point, it has written that the enthalpy at the end of compression is 210 kilojoule per kg. So students, this is the key point to understand the vapor is superheated at the end of compression. Why? The enthalpy at the end of compression is 210 यहाँ पे दिया है, लेकिन just look here at upper limit temperature your Hg will be 206. So 210 means 210 is more than the saturation enthalpy, saturation heat of 206.298 Kelvin kilojoule per kg. So means automatically it will be in the case of saturated superheated compression at the end of after leaving the compressor. Okay, so let's solve. So see here the corresponding TS and pH diagram. Okay, the upper temperature is 50 degrees centigrade, lower temperature is 0 degree centigrade. Convert all the Celsius to Kelvin, that is 50 degrees centigrade means 323 Kelvin, 0 degree means 273 Kelvin. Similarly, the pressure enthalpy diagram, upper pressure is 12.199 bar, lower pressure is 3.086 bar, and the condenser temperature, temperature, refrigeration capacity, all are given in the question. Okay, now as the enthalpy at the end of compression is 210 kilojoule per kg, which is more than the Hg of the table given in the question, so obvious that the point 2 will lie in the superheated state at the end of compression. This is the key point you have to understand. Okay, so let's find one by one enthalpies. So first the enthalpy at point 1, H1 will be Hg1 at 0 degree centigrade temperature. So from the table you can easily find H1 will be 187.397. Similarly, H3 will be HF3 at the rate of 50 degree centigrade, which will be 84.868 kilojoule per kg. Okay, and the process 1 to 2 is your isentropic compression. So entropy at point 1 will be equal to entropy at point 2. S1 will be equal to S2. But S1 in place of S1 you can write SG1, and in place of S2 as it is a superheated state you can directly write S2 dash plus Cp ln T2 by T2 dash. Just students put all the values, you can find the value of temperature T2, it will be 325.59 Kelvin. Now it is very easy to find the COP is your refrigeration effect by work done by the compressor. Result outcomes is 4.536, and heat rejected in the condenser and mass flow rate. Okay, you know 1 TR is equal to 336 into 1000 per divided by 24 into 60 into 60. Okay, so 7 TR will be just multiply with the 7 and the result will be 27.22 kilowatt. And you also know COP can be formed in the COP can be written in the form of refrigeration capacity and power input. So that is COP will be RC by refrigeration capacity by in power input. But you know what is the power input? It is the mass flow rate into the change in enthalpy in the compressor part. Okay, so from this equation you can find the mass flow rate, which will be 0.26 kg per second, and you can easily find what is the heat rejected in the condenser. That is, after getting the mass flow rate, it can be easily be calculated that m dot whole into h2 minus h3. Okay, that is 32.534 kilowatt. Means it is the heat rejection rate in the condenser. If you are not multiplying the mass flow rate, only you will be able to find the heat rejected by the condenser, and the unit will be kilojoule. Similarly, heat extracted rate from the evaporator will be mass flow rate into H1 minus H4. The result will be 26.657 kilowatt. If this is the heat extracted rate, if you are only calculating if the question says find the heat extraction from the evaporator, don't multiply with the mass flow rate. Okay. And what is the power required? Power means you have to multiply the mass flow rate with the change in enthalpy in the compressor part, that is H2 minus H1, and the result will be 5.867 kilowatt. And what is the degree of superheat? The degree of superheat will be T superheated minus T saturated. Okay. So T superheated is your 325. This one. This is your T superheated, and T saturated is your 50 degree, means 323. Okay, so this is your final result. Okay, students. So up to this we have covered the superheated vapor at the end of compression. Thank you.